This is the demonstration for Lab 13A, Ballistic Pendulum. We've previously used this apparatus when we dealt with Lab 13B, which was projectile motion. Now, it is the same apparatus, but this time we're going to be measuring a few different things. In the projectile motion lab, we had a metal ball which was fired from a spring gun and traveled some distance. Now, the purpose of that lab was to basically understand how force is applied to some object, and that object will travel through space given and governed by our kinematic equations. Now, that object is subject to some external force, which is gravity, which causes the object to stop moving. This time, we're actually intentionally moving this pendulum arm down and then firing the ball. What we're looking at in this lab is essentially conservation of momentum and the conservation of potential energy. Taking a closer look at the individual components of this apparatus, we can break this system down into 3 different parts. The initial stage, where the ball begins to move with kinetic energy. We can then stop at the collision between the ball and our pendulum, and then we can look at the third part, which is the pendulum and the ball moving together. Now, in the first part of the experiment, the spring potential energy is at a maximum. Once we decide to start the experiment by firing that ball, all of that energy is transferred to the ball, and therefore the ball gains a max kinetic energy. That number, or that value for energy, is at a maximum until it collides with our pendulum. Empirically, what you'll see is a huge loss of energy. Now, that loss isn't enough to stop the ball and the pendulum from moving. In fact, what it does is switches to gravitational potential energy. As the two start moving upwards, it gains a gravitational potential energy. And so at each of these different parts, we should more or less see the total mechanical energy be equal to each other. In previous labs, we have looked at how force is applied to an object and how that object will then move. As we see in the first stage of this experiment, the force applied by the spring to the ball causes the ball to move. Another way to look at this is, let's say, the ball has some force applied to it, and once it starts moving, or rather once it has a sort of a kinetic energy, we can also say that the ball has some sort of momentum associated with it. Now, in the last segment, I talked about how the total mechanical energy is conserved. What we'll see in the sort of collision of this experiment is the momentum is conserved as well. We have the initial momentum of the ball, and once it collides with the pendulum, that also transfers some of the energy. In other words, it transfers some of its momentum to that pendulum. And now that the pendulum and the ball are moving together, it also has some sort of momentum. The initial momentum and the final momentum should also be conserved in this experiment.